Hi there! For this video, we'll be discussing rationalization. Specifically, we'll apply this on denominators. So basically, the process of rationalization is the process of removing a radical from either the numerator or denominator by multiplying a certain factor that is equal to 1. So let's have this first example. Let's have 2 over square root of 2. Now, how do we remove this radical in the denominator? Well, recall that by the first law of radicals, we know that the nth root of x raised to n is equal to x. So how can we make this the case for the denominator? What should we multiply? Note that let's put it down, since square root of 2, we know that 2 has an exponent of 1, and the index here, since it is not present, it is simply 2. Then our goal is to make the exponent here be 2. So we know that we need to multiply a square root of 2 raised to 1 as well, or simply square root of 2. So we'll have out here square root of 2 over square root of 2. Simplifying, we'll have in the numerator 2 square root of 2, and in the denominator, we have, by multiplying radicals, we simply multiply the radicand inside, which is square root of 2 squared. So now, this one simplifies here into 2 square root of 2 over 2. And to simplify further, we can cancel this one out to obtain square root of 2. And this one out here is the answer. Let's have this next example. Let's have a over the cube root of b. So what do we need to multiply in this case? Well, again, we first observe this one. Observe that cube root of b out here, b has an exponent of 1. So again, by the first law, we need to make this one be 3. So how do we do that? We multiply the cube root of b squared. So we'll have out here the cube root of b squared times the cube root of b squared. Again, why did we multiply this? Since if we had the exponent out here 1, let's put it down here, 1 plus 2, that is equal to 3. So we'll be able to cancel the radical. So we have this one is equal to the numerator a cube root of b squared all over cube root of b raised to 1 plus 2. This is equal to a cube root of b squared over cube root of b cubed. And then we can simplify this one out here. So our final answer is a cube root of b squared over b. And this one is the answer for this problem. let's go on with a harder example. Let's have 2 over square root of 5 plus square root of 3. So what do we need to multiply? Maybe we're thinking of square root of 3 to cancel this one. If we try that one, then this outcome will be 2 square root of 3 over square root of 5 times square root of 3 plus square root of 3 squared out here. This will become 2 square root of 3 over square root of 15 plus 3. So we still have a radical in the denominator. So it must not be square root of 3 over square root of 3. If we try, how about this one? Let's try square root of 5 over square root of 5. Well, you can verify that upon multiplying square root of 5 over square root of 5, the outcome will be 2 square root of 5 over 5 plus square root of 50. So we still have a radical in the denominator. So what should we multiply instead? Well, recall that in multiplying binomials, we have what we call the sum and difference. Or basically, when we have a plus b times a minus b, the outcome is a squared minus b squared. And why do you think this is useful in this case? It is useful since we'll be able to square both the first term and the second term. So in this case, we'll be able to square the first term and the second term in the denominator. Indeed, let's show that one. If we multiply its difference, since this is sum, we multiply square root of 5 minus square root of 3 over square root of 5 minus square root of 3. In the numerator, we'll have 2 times square root of 5 minus square root of 3 all over by sum and difference. This is simply square the first term, square this, minus square root of 3 square. And note that this one out here simplifies into 2 times square root of 5 minus square root of 3 over 5 minus 3. And so, this one simply simplifies to 2 times square root of 5 minus square root of 3 over 5 minus 3 is 2, cancelling out the 2, and our final answer is square root of 5 minus square root of 3. And this is the answer. So, there are some problems wherein we will use this sum and difference product concept. Let's try this fourth example. Let's have 4 over 4 minus I. Now recall that I is equal to square root of negative 1. So we have a radical in the denominator. Applying what we did a while ago, we multiply. Since this is a difference, we multiply the sum, which is 4 plus I over 4 plus I. So in the numerator, we will have 4 times 4 plus I all over. In the denominator, we'll have the square of the first term minus the square of the second term. This one is equal to, simplifying the numerator, so we distribute this 4 out here. That will give us 16 plus 4i. And in the denominator, we have 4 squared is 16. And I squared is, recall that in our imaginary number video, I squared is equal to -1. Simplifying, this one is 16 plus 4i over 16 minus -1. Basically, what we do here is we multiply this negative sign to obtain 16 plus 1, or simply 16 plus 4i over 17. And this one is the answer. Let's try out this one last example. Let's have 1 over the cube root of x plus 1. Note that we can't really apply the strategy that we did a while ago, since this is already cube, or an index of 3. What if we try to apply our first method of multiplying a monomial? Since this is cube root of x, we must probably multiply cube root of x squared. Let's try. The outcome here is, numerator is cube root of x squared, denominator is cube root of x times cube root of x squared is cube root of x cubed plus cube root of x. Simplifying, this one will be equal to 1. Will be equal to x, since the radical and the exponent will cancel out. So we'll have here x. So we still have a radical, unfortunately, in here. So far, our methods are useless in this example. So we try to recall another thing that we have discussed. Recall that if we have a cube plus b cube, this one factors into a plus b times a squared minus ab plus b squared. So where did this came from? This came from the idea of sum of two cubes. Basically, this is present in our factoring playlist, so you can check that one out. So we'll use this idea in this example. Let's skip this one in here as a guide. So to determine what we will multiply, we can view this one out here as this binomial out here. So this one, if we represent this one as A and we represent 1 as B, then what we need to multiply out here is this one. So we've got a squared out here, which is the cube root of x squared. Then we've got b squared out here, which is 1 squared, or simply 1. And then we have ab out here. Multiplying these two, that will simply be the cube root of x. Copy the signs. And we have this. So let's multiply that as well in the numerator. cube root of x squared minus cube root of x plus 1. And now, simplifying this, 1 times this one, the numerator, 1 times this trinomial out here will give us cube root of x squared minus cube root of x plus 1 over, we know that when we multiply this out here, the answer or the outcome is the cube root of x cube minus 1 cube. This simplifies into cube root of x squared minus the cube root of x plus 1 over this one out here is equal to x. So we've got x here, and 1 cube simply 1. And now we have rationalized the denominator in this example. So this one out here is the answer. So basically, the concept of sum of two cubes, or sometimes difference of two cubes, is useful when we encounter a cube root. So take note of that one. So before I present to you some example, here's just a quick summary of the strategies or techniques that we can use to rationalize the denominator. First is to multiply a monomial. So the thing that we need to recall here is this one. So we must find a way to multiply a certain factor to make this one the case. So this is for monomials, or just one radical in the denominator. Now for binomials, we take note of the sum and difference technique, or the sum of two cubes or difference of two cubes. So this one out here is basically used for if we have square root of x plus square root of y in the denominator, or minus. And this one is useful if we have cube root of x plus minus cube root of y in the denominator. So take note of these techniques. And as an exercises, since we have prepared two exercises here, you can work on rationalizing 2 square root of 5 minus 3 square root of 3 over 2 square root of 5 plus 3 square root of 3. For the next one, we have 2 over the cube root of x minus the cube root of y. There, just fix it. So you can work on these two exercises to improve your skills in rationalizing the denominator. So that's it for this video. I hope you enjoyed it, and feel free to comment down below your answers and solutions to these exercises. So that's it, and that is all for this video.